Now we talked about a common raw material. Common raw material would mean that this amount gets consumed in Q as well as in P. So if you want to make one of Q, one of P, you'll have to make two of the common raw material. See, what we started off with a very simple manufacturing organization which just made Q, it can not remain so simple. It leads to some sort of a overlap, complication, conditions, okay, which is nothing called but the limiting factors. So now, if you look at it, you have the routings, that means the stages in which the raw material get converted into finished goods. You know where the common raw material 2 gets assembled with raw material 1 or 3, and we have this. It may sound a bit complicated, but let me simplify it. Let me put to you a pictorial layout of such a process, and here it is. This is called a process layout of a company. Let me try and explain the elements that make this process layout. You have a routing which tells you in what sequence does raw materials get processed, and at what point in the processing do you require raw material 1 to merge with raw material 2 or raw material 2 to merge with raw material 3. And at every stage of production, you know which resource is working on the raw material and for how many minutes. This is to let you know the effort. Now, more or less, you have all the data that you require to do your calculation to find out how much of profit will you make by the end of the week. You have a demand which is very predictable. That means if you make 100 pieces of P, it will be sold. If you make 101, that one piece will not be sold. The raw material will arrive on time. So that takes your excuse that I was not able to sell because there's no raw material available. Raw material is available, the predictability of the outcome of the manufacturing process is certain. That means whatever needs to be produced will be produced in the time it has been said it will be done. Here is your ideal manufacturing environment. No setup costs. So if you move from one product to second product on a resource, no setup change, still bigger comfort. So what this ideal environment does is it takes away all the uncertainties. Now let us see how much of profit we will make. We all begin in a systematic way. Remember one thing, being systematic does not mean being correct. Whenever in a company we are doing such an exercise, it's a common practice to have at least one person from finance and accounts, one person from marketing, and one person from production. The reason why I'm beginning with these three examples is they all have a different approach to thinking. And this is what is going to play out once we start analyzing the figures they calculate. The data we have is P, which is sold at 90 rupees per unit. For this, the demand is 100 units per week. For Q, is sold at 100 rupees and the demand is 50 units per week. Marketing person systematically begins to calculate how much of money they will make. Demand multiplied by selling price of P and Q and sums it up. Comes to a figure of 14,000 rupees as revenues. From this, he says, if I minus my raw material cost, if I minus my operation cost, I will be able to make a profit. So his calculations looks like this: 14,000 revenue, which is nothing but he's selling 90 rupees, selling price of P into 100, that is 9,000. He's selling Q at 100 rupees and is selling 50 of that, that is 5,000. 9,000 plus 5,000 is 14,000. His revenue figure of 14,000, from which he says he will minus the raw material cost. The raw material cost is 6,500. Now, from this remaining amount, he will pay the operating cost, which is another 6,000 as given to us in the data. He says, sir, we will end up making 1,500 rupees as profit by the end of the week. Good figure. He raises his hand and says, sir, with the current business plan that we have, this is the demand, and if we are able to sell the demand, we will make 1,500. To which the production guy says, the demand is okay, but do you think we will be able to produce it? The production person makes his calculation and says, one of my resource works 8 hours a day and 5 days a week. This is equal to 2,400 minutes per week. I have 4 different resources, so the total time available to me is 9,600 minutes. In this amount of time, I have to meet this demand. Let me see and calculate if I can meet it. He makes a calculation. I have to make 100 of P. It takes me 60 minutes to make P. 60 into 100, 6,000 minutes of my resources will be consumed by P. I have to make 50 of Q. It takes 50 minutes to make 1 of Q. 2,500 minutes of my resource time will be required to make Q. Total put together, it comes to 8,500 minutes. Total time available, 9,600 minutes. I can make it. He's systematic. He tells you that it is possible. This is one way of calculating. And you go ahead and you say, okay, what the marketing person says is probably possible. Let's see what the accountant does. The accountant says, let me see how much of money is being spent per minute of the effort and if that is profitable or not. So what he will do, he will take the total overall expenses, divide this expense by the per minute effort that goes in converting raw material into finished good and come to a figure. He will also come to a figure and say, yes, I think it is profitable. So we have checked that the demand can be fulfilled. There is a time available. We still have some capacity left. The costing fellow says, okay, there's no problems. We are well within our cost range. I think we can go out and give a commitment that we will make 1,500 rupees as profit this week. However, have we checked in detail that can we produce this? To check in detail that we can produce these numbers, we have to go one step further down and do a calculation of the amount of load this demand places on each of my resources. In other words, if I have to sell this demand mix of 100 Ps and 50 Qs, what kind of manufacturing load comes on my resources? Only then can you understand what exactly is going to limit the production. And if there is no constraint there, the demand can be very easily fulfilled. In other words, you can make a promise which can be kept. The biggest problem is if you have accepted this demand and later on, because of a limiting factor, because of a constraint available in your operations, you are not able to satisfy this demand, the impact of that not delivery is phenomenal. Let's go back and systematically calculate the load. Here is one way of doing it. You take P and you take Q in two columns. To make 100 units of P, you refer to the routing. You will find out it needs 15 minutes of A to process raw material 1. That means resource A will take 15 minutes of its available capacity to make 1 of P. Total time taken by A, 1500 minutes. Let's go to resource B, raw material 1 and raw material 2. Both these raw materials are required to make P. Total time required for P is 15 minutes by resource B. Total amount of load placed on machine B for making 100 units of P is 1500. When you go to C, it takes 15 minutes to process 1 raw material which will go inside P. Total time taken by resource C for making 100 units of P, 1500. Raw material 1 and raw material 2 come together at station D to be converted into final product P, which takes another 15 minutes per unit. So P puts a load of another 1500 minutes on resource D. So what you see is A, B, C, D resources loaded by 1500 minutes each to meet the demand of 100 units of P. Let's go and do a similar calculation for Q. For resource A, item Q, product Q places a load of 10 minutes per unit. We are going to make 50 of Q, so the load on machine A is 500 minutes. The machine B works on raw material 3 as well as on raw material 2. One of each of these raw material is required to make 1 of item Q. So total time required by machine B to make 1 unit of Q will be 30 minutes. The total number of units we want to make are 50. So the total load placed on resource B to manufacture 50 units of Q is 1500 minutes. Machine C spends 5 minutes on raw material 2, which is a common raw material only, and since we are making 50 units of Q, which requires 1 each of raw material 2, 50 into 5, that means 250 minutes of load comes on machine C because of making 50 units of Q. Let's go to machine D. Machine D also needs 5 minutes of processing time to make 1 of Q, and for this 5 minutes it uses 1 of raw material 2 and 1 of raw material 3. So the total load for making 50 units of Q come to 250 minutes on machine D. If you look at the chart, it looks like this. You have product P and product Q. They have a demand of 100 and 50. And for this demand, the manufacturing resource requirement time is like this. A, B, C, D, 1500, 1500, 1500, 1500. For Q, 500, 1500, 250, 250. We sum it up. We find that machine A is loaded for 2000 minutes for the week. Machine B is loaded for 3000 minutes for the week. Machine C is loaded for 1750 minutes a week. And machine D is loaded for 1750 minutes a week. Though there is surplus capacity available on A, C and D, machine B seems to be overloaded. What does overload mean? Overload means that we cannot satisfy the demand. Since the available number of minutes is just 2400 minutes, we are left with a situation, what can we do with this 2400 minutes so that I make the maximum money? Put other way, since the demand I thought I will satisfy puts a load of 3000 minutes on resource B, I have to find a way of either finding 600 extra minutes, which seems to be impossible in the period of time that I'm trying to make this money. So now I have to let go of certain number of units. Now the big question is whether I should let go of Q units or I should let go of P units.